Welcome back. This is Sachin again, and actually today I will be talking about Kafka streams, and this project uh, is something very interesting, at least for me, and I'm sure you guys will also enjoy and learn something along with me. So, um, uh, so very first thing, I will be not focusing too much on theory. Um, so I'm assuming that you guys have some basic information about Kafka streams or K tables. Um, the intent to create this video is like when a couple of years back when I was learning Kafka Stream, I really wanted to do something to quickly get up and it started, which includes your Kafka clusters, the Zookeeper cluster, and why I'm saying cluster because sometimes I want to try how exactly they will work in a production environment. What if one node Kafka broker gets down? What happens to your application? Let's say you're working in your Kafka stream applications and which is listening to a topic which is having multiple number of partitions, and then you are running multiple consumer applications. What happens in case of rebalancing? And then to try all that thing, I need to run a cluster and where I will kill one, let's say streaming application, and then I want to see the local store. Don't worry about too much terms if you I mean, if it bothers you, you don't have to understand like everything, but just to get an idea that multiple streaming applications are running and they actually internally create some kind of a store. What if that crashes? It should get a spin somewhere else. So actually, the intent of this project is to make things super simple, which will be a matter of you guys need to just check out the project and run it. This is a very simple example. I'll be using it. So basically, to give you an idea, I have a pre-baked data for employee I randomly created, which is an ID, gender, name, and department ID. That's what I'm using. The rest of the field I'm not using, at least for this demo. And the very simple problem statement is I want to figure it out how many number of employees for each department, right? So before we get a start, few things you need is like your JDK and Maven in your local environment. That's one thing. And then of course you need a Kafka cluster and a Zookeeper cluster. So let's start that. So actually, in my previous videos, I have already covered in details how to use Minikube, which I'm currently running VirtualBox Manager, and how to run your Kafka and Zookeeper cluster in a local environment. I'll be not spending too much of time, but just to give you a recap, this is the link, and I will be sharing in the description as well. It's a Kubernetes sample. This will help you to basically bring up any of these components, whatever you see over here, like Kafka, MongoDB. Monitoring is something which I'm currently working, so just ignore it. Nginx and Postgres and Redis, mostly in a clustered environment. So for example, if I have to run a Zookeeper cluster, what I'm gonna do here is basically I'll be running this script. So Zookeeper and has a run.sh. As this project I have already checked out, let me go to Zookeeper and then run.sh. All right, so I'm going to spin my Zookeeper, and then the first thing is I just put a -h option. And usually most of these scripts, at least in this project, will have a -c option. So if you want to run a clustered mode, then you have to provide a -c option. So what I'm going to do here is -c. So that will bring my C node cluster. If you don't want, it takes a little time to bring up all three clusters. I'm using stateful sets. If you don't want to wait, just want to quickly bring up and running for Zookeeper for some of your testing to shut it down, just skip this option. Then in that case, you just run one node Zookeeper in your local environment. So let's go with -c and then see what else we need. -f, yes. -f is basically to force cleans. If any Zookeeper is currently running, it will basically clean that namespace or whatever existing resource, and a fresh Zookeeper it will start. So let's hit it. All right, so this has been applied to Kubernetes. And again, it's not a detailed thing how to run Zookeeper and Kafka. I have already covered in details. Please follow that so that it's pretty simple in future for you guys to basically bring up these components in a local environment. So actually it uses Zookeeper namespace. And then let's see what's happening over there. So I see that Zookeeper node 0 has run and the Zookeeper 1 is kind of coming. Once the Zookeeper is up and running, the same thing I'm gonna do here is with the Kafka as well. So, and this time I'll go to Kafka, and then in my other screen, okay, I will run this again. So you can always put -h option series because it is the same thing. -c and f option I'm gonna do here, and I'm just gonna press enter. It takes so basically the Zookeeper, once it's up and running, usually I give my Kafka after that because Kafka internally uses Zookeeper. I'll be pausing my video. Let me get my password. I'll be pausing my video because it takes like a couple of minutes, and once it is up and running, I'll resume that. Okay. Pause. Welcome back. So we have passed sufficient amount of time, actually much more than that. I was doing something. So let's check the Zookeeper pause. This is in Zookeeper namespace, and I see my 3-node Zookeeper is up and running. And by the way, once you start Kafka, it also start Kafka drop. So basically, Kafka drop is basically a monitoring tool for Kafka. We will see that, but first thing first, let's go to Kafka namespace and get the service so that is up and running. And I see 3 service with node 3 0092 9894 port. Okay. Okay. CTL, and Kafka, get parts also, let's check it out. Get parts, wide, show labels. Perfect, all my 3 parts are up and running. And then we have seen that we have Kafka drop also running, and then let's check it out. Yes, perfect. So now my setup is complete. Let's quickly see the project. Okay, so that project is a stream project, and all that GitHub links I will be putting in the description as well. Source main, it comes with data, so employee data, which I'm planning to push into a Kafka topic. But let's see what it scripts. So this is the, okay, so to run this particular demo project is count stream example.demo, which will basically do the streaming part. I'll show the code real quick. So runners count stream example. So this is the basically the driver class. Idea is very simple. We need to find the number of employees on each department, and this is an employee ID, and then after the name is a department ID. Okay, sorry, let's move it out. This is the line which will do the whole magic. It says go to the employee topic and use the byte array. Byte array survey will work every cases because Kafka internally stores all the data in a byte array. So anything you want to consume, byte array is sufficient. So for key, I don't bother because when I'm pushing the key, which you will see, there's no pushing the message, then you will see, but there is no key with that. And the object is basically a JSON. So the plan is to basically take the CSV, convert it into JSON, which will resemble to this Java object. And once you retrieve it, basically you can deserialize into an employee object. Okay, this is the method. And the survey is simple. You guys will see the code separately, but survey is basically stand for serializer and deserializer. And then basically I'm using JSON, serializing JSON deserializer, and then these are already included in the project. You can basically have a look. Okay, that's it. Pretty much there's nothing much here. This single line, where is that? Yeah, this single line will do the heavy lifting. It will tap on the topic, start the streaming, and then while deserializing it, it will, the byte array, the object gets converted into an employee, and then you get in the stream. That's pretty much. And what I'm going to do here is just printing the content. As and when the data we will be pushing into the topic, we will see the consumer application, the streaming application. Here will write the content, of what key and value we are pushing. And the second important line is basically this guy. This will do the whole analytics. Very super simple. It will read the stream and the select key, because the keys, original key is null. From the data, the key value pair, I get the value, get the department ID, convert to string. Why converting a string? Because I will be printing the console, in the console consumer, this topic information, so that you can nicely see over there. Now, once this is department ID is my key, I group it by and aggregate on account. And then I nicely get a string comma long object. A string is a department ID, as you see over here, and the long is a value, the number of employees in that department. And because we will see that the data which we will be pushing is in the real time, so you see the analytics coming in a real time on each event by event. By the way, if in case I'm not sure whether I covered it or not, but the best part of Kafka is basically it can do the analytics event by event. So which is very different than what other players in the market they do is like, let's say Spark. What Spark does, it's not a true streaming, I would say. It does analytics. It's good for batch processing. So basically you can say, okay, tell me all the data which came in the last 1 hour or last 1 minute, and it can do the analytics to achieve the real-time impression. Basically, you can do the micro batching, basically reduce the window size from 1 minute to, let's say, 30 seconds, or let's say 5 seconds, or even a 1 second. So basically in that window you say, okay, give me all the data, and it does analytics to that. Unlike Kafka, where you can do the analytics on every event. If you are getting, let's say, thousands of events per second, you can do the analytics on each and every event, which is very important distinction. All right, that's pretty much. Once I get this object, I can only stream, and then just values this one. This is just for printing purpose. So I show it to you, that in my consumer, that value is coming, and I'm pushing it into another topic employee count, which will just keep the count for each department. What is the count? All right, the count also I'm converting into a string, so that basically I can show it to in your console consumer, but that need not to be a string. That's pretty much. And then I'm also printing it in the application as well, so you can see. This is all my very simple string, which is doing a very heavy lifting. It taps on a topic, reads all the data in real time, do the massaging or mapping transformation of the data, and doing the analytics, saving the result into another topic. Quite powerful. All right, so the first thing we need to do is basically push the data into this object. So if I haven't shown the script for now, you don't have to do anything, just keep blindly run that scripts and just change the value according to your needs. So my plan is, let's say, demo-001. This is the topic I will be pushing the information. So if you see my Kafka drop, this topic doesn't, there is actually, it's a fresh setup. So there is no topic exists as of now. This is the topic I will be pushing information. I'll be pushing information very slowly, like it's not like dump everything and doing the analytics. There's no fun in that. It will be like push all these records every, let's say, 10 milliseconds. And then we will run the consumer application in a highly available and clustered manner. Not highly available, but into separate terminal. And let's see, let's get it started. So, and this is the application ID. So let me also give it 001. So this script will, okay, let me open a new terminal. Let me do the bigger font. Okay, in these two terminals, I will be running the same application. So basically, they will be sharing the same application ID. So they will be working together. It's not like 2 times I'm running. It's different than that. Basically, they will share the load. So if you see here, And if you're aware about how internally it works, basically, if you're pushing information into a Kafka topic, which has tens of partitions, I'm not going to do that, but you can try on your own. I'll highly encourage that. There are tasks created, which is basically with the number of partitions, right? And then because I'm running into two different things, they will share the load. Some of the tasks will run in this terminal and the remaining load will be shared into another terminal. And there will be like different sub topologies. So basically one will work basically to create this stream and basically print the content. Another one is probably, might be doing the aggregation of that. So that way, we'll see how it works. All right, so let's get push some data. So by the way, I have also included and covered my previous video and put the link again in the description, but this script will push some information into a Kafka topic in a real-time manner. So basically, if you just see the help option, what it says that first of all, you need to build that project. If you haven't done it, do it one time, but that's required only first time. You don't have to build each and every time. It'll create a Docker image. And then there are two required fields. The one is the file, basically the CSV file, which I have shown. I'm planning to push that CSV file information into a Kafka topic. And this utility will read that with the duration which you give. If you don't omit this information, the default is 1 second or 2 seconds. You need to check. And then the topic, what topic you want to push that information. By the way, I have already created an alias, so I'm not going to directly click because my Kafka servers are running into this. So this is like pre-baked, some kind of a alias. So I don't have to give my servers each and every time. Most likely you'll be running Kafka in your local, let's say. So just skip that. In that case, it will take your local host as a default one. But if you're running Kafka in cluster or like in some cloud environment, just feel free to give that IP:4 separate by comma if it's a clustered one. All right. So that case, let's quickly see the help once again. And I have already put a small information over here. Give the file and the topic name and the duration, whatever you like. So that's what I'm going to do here. KS, and this is the path-f. And then this is the topic duration is 10 milliseconds, I said. And my topic name, I am planning to push information into this topic. That's it. Okay, now this will push the information, this topic, and these guys will start working, read the topic, print it in this console itself, and push it into another topic as well. By default, if I don't create the topic, the Kafka will create the topic. I mean, when the producer API will, which internally is running in the Steam application, will create a topic. But that's how I want it, because you think about like a stream of data is like continuously flowing. This will analyze and push information into a topic. Now, eventually my data will be correct when it reaches into the topic, but I want some kind of a compaction also happens in that place, because end of the day, I want a result for, I mean, one key, there should be only one data. Otherwise it will say something like, let's say your key is 49 in this case, you'll see here. As and when like 5 records have come, and then there will be one record in the topic. It says, okay, a department ID 49 has 5 count, and now another count came. So this will again push another record that department ID 49 has 6 count. I don't want to see that. I want to see the final result. So let's create a compaction topic. And those who have followed my previous tutorial and they have seen how to run a Kafka and Zookeeper cluster in your local Kubernetes environment, they're aware about another script, and I think this is in another project. Kafka, yes, okay, this guy. So you just ask for -help, and there is an option for extended help, which tells some useful commands which I usually try out. So here it is. Okay, this includes the command to basically run a compacted topic, right? So what I'm going to do here is the result topic, which is my count topic. I am going to create it beforehand. As a topic, this guy. If I don't give it, will create a topic, but that will not be a compacted topic and it will not be easy to see information over here. Okay, by the way, because every time I start my Kafka internally, um, I don't use the default or the root path I usually give. Every time I start Kafka, it uses a different Zookeeper node altogether, and that node name is here. But if you want to see the node name on your own, if I'm assuming if you have seen my previous videos, so basically what you need to give is dot app dot zkcli. Let's go inside Zookeeper and say ls slash, and this is the node name it creates. So basically, whatever it is, don't bother too much. I mean, it's your setup. Just provide the Zookeeper which you have given in your Kafka. That's it. And then there was one more thing left. Is let me see hyphen extended help, and I need to go to my pod first. Okay, because I will be coming here. So let's go to the pod. Okay, I'm inside the pod, and I'm gonna create a topic here. Perfect. So my this topic has been created, and if you want to see your Kafka drop, just refresh it. Okay, this topic has been created. If you click, you will see more information about it. The 3 is the number of partitions I gave over here, can be validated here. The partition count should be 3 somewhere, yes. And it's a compaction topic, so cleanup policy is compact, and the information you see over here is pretty much in the command itself. So my result topic is created now. Only thing left is to push the data and start my streaming project. And let me prepare the setup for that as well. Come on, let me copy this. Okay. Okay. All right, these 2 commands are ready. Okay, all set. Let's push the data over here. And once it starts, I will start my streaming applications as well. All right, I will start my streaming application both the terminals. Remember that they are working as a cluster. So basically, half of the load will be shared by this application, and another half will be shared by this application. Okay. I think this ran very fast. Let me let me rerun once again with a little higher duration. So it takes some time to finish it. I'm again pushing the same data. So we see some information printed over here. Okay. And we see that okay. Okay, it's running very fast actually. So this is printing original content. So, and this guy is printing for depth. So this is actually, I want to show you that, these guys are like sharing the load. The one topology is being run on the right side where it is printing the original content. Another half of the topology, which is like actually doing the aggregation, is printed in this another one. And you see that they are not crossing paths of each other. And as and when data is coming, it is actually, this is the final result. Like for department, this was the count. As and when the data is coming over here, this is printing it. This is very strong finding, I would say. If you have multiple topologies and you can start multiple terminals or basically run another machine, and that's where you can, up scale out. Okay, all right, that's pretty much. Now the only thing is left to show you how we see the data in actual consumer side. All right. So we see that, for key 30, this is like department ID 33, there are 40 such records. If I remember correctly, for department ID 49, there were 22 records, and then 2022, because I ran it 2 times, it should be something like 44. And let me check it. I might be wrong, but just let's check it out. Yeah, right. So because I know my this data, which you can find in your Git repository as well, the um, department ID with 49, like these kind of records, there are 22 records. So total, once this program is run, you should see the result as 22, because I ran it 2 times, you will see the result at 44. So that's pretty much for today. Um, I personally find the analytics done by Kafka very interesting because of event by event, it can do the analytics. All right. If you like this video, please give me a thumbs up. Thank you.